All right, ladies and gentlemen, so we are going to be formally taking a look at acids, bases, and the pH scale. So, like I said, yesterday we sort of did an introductory foray into acids and bases. We learned some things with our ed puzzle. And then we had our little activity where we got to sort of play with the pH scale a little bit on the PHET website. And so now we are going to take a look at some acids and bases. All right. So, everybody can name some acids and bases that are pretty familiar to them. So think of like some acids, things that like some common things that you drink. What are some common things other than water that you drink? Anybody? Pop. Yep. What else? Lemonade. What else? Anything besides pop and lemonade that we drink? Coffee. Okay. So, ladies and gentlemen, lemonade for sure. Coffee for sure. What's that? Energy drinks. Okay, cool. Um, pop. Awesome. Anything else? Okay. Yeah. So pretty much everything that you guys just named is acidic. Lemonade for sure is acidic. Most juices, in fact, I can't think of any juice that isn't, but I'm gonna say most. Well, the reason why you have bubbles is the reason, at least with pop, actually explains the reason why it's acidic. Because when we make pop, we put carbon dioxide gas into the pop. That's what creates the bubbles. But as those bubbles kind of work their way through the water, that's what actually makes it into the carbonic acid, which is what makes pop slightly acidic. It's not like super acidic. It's not going to destroy, burn your skin or anything like that. But it does have a pH of around 5-ish. I mean, I haven't obviously tested every single pop on the planet, but that seems to be about the average for pops. Any citrus, by the way, is going to be acidic. So I'm sure you've heard of if you've ever gotten like lemon juice or orange juice, if you're squeezing them, or lime juice in your eye, that hurts. Yeah, but the reason it's hurting is because it's an acid. It's not going to do any horrible damage because it's not a very very strong acid, but it is. It is acidic. Bases. Now, not for any, most of the time people don't really know bases. We know acids because of the things that we eat, the things that we drink. Pretty much anything that you're going to use to commonly clean your house. So again, I'm saying common household items for cleaning. So whether we're talking ammonia or oven cleaner or drain cleaner or soaps, detergents, things like that, those are all pretty much bases. I'm not saying every cleaning product on the planet, but I'm saying the most common ones are like your Windex that you use to clean like your glass and stuff like that. These things are all bases. All right. And again, acids, we know from the video yesterday, have a pH of 0 to basically 7. We know 7 is neutral. And we know that bases go from just above 7 all the way to 14. The further away you get from 7, the stronger is the acid, the stronger is the base. All right, so what are some properties of acids? So this is going to help you get through slide number 3. I'm sorry, the first 6 questions on this is slide 3, so to help you get through the first 6 answers on your notes. All right, so first of all, acids taste sour. Um, if you've ever drank pop, certain pops are definitely more sour than others. Most juices have that little bit of sour hit in the back of your mouth. Acids have a sour taste to them. Litmus paper is a tool that scientists use to test for acids or bases. Now, there is red litmus paper and there's blue litmus paper. If you use red litmus paper and put it in an acid, it stays red. If you take blue litmus paper and you put it in an acid, it turns red. So acids always turn litmus paper red. Acids conduct electricity. Um, your batteries, whether it's a 9-volt battery, like you might have like in a speaker, whether it's a rechargeable battery like you have in your phone, whether it's the battery in your parents' car, whether it's like the TV remote battery, those little AA or maybe AAA cells, all of those things have bitter supplies, battery acid in them. And the reason why we use acids in batteries is because they're really good at conducting electricity. Acids are extremely corrosive to metals. If you get an acid on a metal, it's going to rust and break down that metal very quickly. For those of you who maybe ever left your bike out in the rain, you know that that chain and the gear sets turn rusty pretty quickly. And the reason why is because, and I'm not trying to be funny when I say this, and it's nothing that's going to harm you, so nobody freak out. But all rain is slightly acidic. Now, there is stuff that we call acid rain, which is more acidic than regular rain, but pretty much all rain is mildly acidic. So when you leave your bike out in the rain, that's why it rusts so quickly. That acid that is in the natural rain is going to start breaking down the metal of your gears and your chain and things like that. Acids react very quickly with metals, and acids will always react with a base to produce salt. Okay? Um, any questions on the properties of acids? And again, like normal, I will probably videotape this and then add it to the notes later. So if there's any part of this that you missed, you can always watch the YouTube video later on. All right, properties of bases. So this is question 2, numbers 1 through 6 in your note pack. So properties of bases. Um, so if acids taste sour, bases taste bitter. Okay. Um, Remember that litmus paper that we just talked about? It's just like a little piece of paper that scientists can use to test for acids or bases. So litmus paper will turn blue in the presence of a base. So blue litmus paper stays blue, and red litmus paper turns blue. So if I had red litmus paper and I dip it into something and it comes out blue, I know that that thing is a base. Bases also conduct electricity, not as well as acids do. People always think that acids are more dangerous than bases. Bases can be very, very corrosive. And it's not about whether it's an acid or base as to whether or not it's dangerous to be around people. It's about the strength. How far away from 7 is that acid? How far away from 7 is that base? Keep in mind, water is neutral and the human body is mostly water. So neutral is good, right? Um, but bases are very, very corrosive as well. I want you to keep in mind that your drain cleaners, like so your drain gets all like clogged up, just nasty, the water's not flowing, it's gross, there's hairballs or grease traps or whatever disgusting thing is happening down in your drain cleaner that you use to clean it out, to move all that gunk and dissolve all that gunk, that's a base. And we know that if you get drain cleaner like on your skin, you need to rinse off immediately, because it literally will, just like an acid, react with your skin and cause a chemical burn. So they are very, very corrosive. If you were to feel a base, and you know this from cleaning materials, they have sort of a slippery feel to them. That's, by the way, why they're such good cleaners, because they will attract the oils and greases and things like that. And then when you rinse whatever you're cleaning, it slides right off. So that slipperiness is what makes them good cleaners. And again, base, just like acids react with base to make salts, well, guess what? Bases react with acids to produce salt and to produce water. That reaction of an acid and a base that makes a salt and water is what we call a neutralization reaction. But we'll get more to that in a little bit. So examples of acid, we've talked about some of these already. Examples of acid, and this is number 3 on your notes catcher. Um, Acetic acid, very, very common acid, is the acid that you find in vinegar. Absorbic acid is the acid that we find in citrus fruit. So, oranges, lemons, limes, that is ascorbic acid. By the way, a lot of your favorite fruit flavored candies, like your Sour Patch Kids, Skittles, things like that, they also have ascorbic acid in it. In fact, anything that is going to have an artificial fruit flavor in it has ascorbic acid in it. So acetic acid, ascorbic acid, they're pretty weak acids, just FYI. Hydrochloric acid. Hydrochloric acid is a very strong acid. It breaks things down fairly quickly. This is your stomach acid. Now, we can find hydrochloric acid in other things as well, but it is the acid in your stomach that we use for digestion. So you're like, well, if it's such a strong acid, why doesn't it eat through my stomach? Your stomach is literally lined. I know this is mildly disgusting, so sorry. Your stomach is literally lined in like mucus, kind of like like you have in your nose. You have a mucus membrane that surrounds your stomach and protects it from that acid. If you know anybody who has a stomach ulcer, an ulcer is a thinning of or a literal hole in your stomach. And that happens when, for whatever reason, that mucous membrane it gets too thin, or maybe disappears entirely, and then that hydrochloric acid does actually eat through the lining of your stomach. A lot of people say that it's because you eat too many spicy foods and this and that and the other. There's lots of reasons why people get stomach ulcers, and there's plenty of people who eat tons of spicy food who don't get them. So it's just one of those things. If you feel that you're having problems with your digestion, a lot of stomach pain, as I would always say, seek medical attention. Phosphoric acid, we use in a lot of soft drinks. We use phosphoric acid as well in fertilizers. And nitric acid is hard to come by for good reason. Nitric acid is used in explosives. So remember how we said that acids are pretty reactive? Yeah, you can actually get them to react and be a base for explosives. So if you were like in the construction industry and you had to I'm sure you've seen on TV anyways, where they implode buildings, like they did the Pontiac Silverdome a few years ago, the Hudson building probably before you guys could even remember. Whenever they implode a building, they use explosives, and we need nitric acid to make those explosives. All right, common bases. This is number 4 on your note catcher. Ammonia. And hopefully you all know that ammonia is a cleaning product. It's a very common cleaning product. And even if you're like, well, we don't use that because it smells horrible. Even if you don't use ammonia as straight ammonia, you will find it in other cleaning products. Potassium hydroxide. Is the beginning of a lot of soaps. So, like your body soaps, your shampoos, detergents, a lot of potassium hydroxide, common base that we have in some very common household items. Sodium bicarbonate is the chemical name for baking soda, which, duh, we use in baking. And then you can also use baking soda for cleaning. Back in the day, before people actually had actual toothpaste, people would literally this was the first toothpaste people used to just pure baking soda. And nowadays we add baking soda to toothpaste, but that's not all that's in there. Calcium carbonate, again, this is the chemical formula CaCO3 for like Tums. So again, remember, some people who have upset stomach and we have all the acid in our stomach, you add a base, calcium carbonate, you get a neutralization reaction, and your stomach can calm down. And sodium hydroxide, NaOH, is a very, very strong base, and it's found in lye. This is the kind of stuff that we use for drain cleaner. Very, very strong stuff. Very, very high pH, close to 13, 14 range. All right, so Whoops, did not mean to go that fast. All right, so acids, vitamin C, folic acid. I don't know if any of you guys have any friends, family members, acquaintances who are currently or family friends that are pregnant. Folic acid extremely important for pregnant women. If you have very low levels of folic acid in your body when you are pregnant, there can be some birth defects to the child. So when people do the whole like take your multivitamin that they give to pregnant women, there's always folic acid in that multivitamin. Lemons, limes, oranges, grapes, vinegar, tomatoes, these are all common acids that you probably have around the house. Bases that you probably have around your house: baking soda, drain cleaner, window cleaner, floor cleaner, pretty much any cleaner. And acids. I hear somebody unmuted. Was there a question? Okay. So, as a general rule, if it's fruity, it's an acid. And if you use it for cleaning, it's a base. Easy peasy way to tell the difference between the two. All right, so we are now on. Yep, I think I'm there. Yep, this is going to be number 5, just so that you guys know. All right, so for number 5, the different. So we have. Well, actually, this and the next one is going to be 5. So, what the heck is an actual acid? What an acid is an acid ionizes. What that means is it breaks apart water. So you know how like water is like 2 hydrogens and 1 oxygen? So that hydrogen bond causes one of your hydrogens to literally pop off of water. So now we have, and we say we could be H3O positive, or we just say positive H. I prefer referring it to as just like a hydrogen ion. A strong acid is a strong electrolyte. What an electrolyte is a solution that can conduct electricity. A weak acid does not ionize completely. So a weak acid is not going to be able to break that water molecule, that hydrogen off completely in a water solution. And weak acids, of course, are going to be weak electrolytes. So, as a general rule, if you want a really strong battery, you need to have a really strong acid. This is why, as a general rule, when you dispose of like your old cell phones or your old electronics or your batteries or your car batteries or really anything with the battery, you're not supposed to throw it in the regular trash, because most of these batteries have very, very, very strong acids, and then it becomes like an environmental sort of issue.
So that's why when you put your tongue on the battery, it tastes weird, right?
When you put your tongue on a battery, what you're actually feeling is the electricity of the battery flowing through you, and it sort of has that sort of like zinged feeling or almost a zing taste. But yes, no, if you were to actually put your tongue to the acid that's in that battery, it would chemically burn your tongue.
Right.
So not a great idea to do that. But yes, I'm gonna stand here and be like, yep, and I totally used to do that when I was a kid. So most children do this, but it's not a great idea. All right. Moving. All right. So in terms of examples, sulfuric acid, very, very strong. Sulfuric acid is battery acid. Phosphoric acid is pretty freaking weak. And again, remember that phosphoric acid is the one that we normally tend to see in pop, right? Or in those carbonated energy drinks. So again, they are acidic, but they're a very, very weak acid. All right, bases. So if water is H2O, and for an acid to be formed, we kind of pop off one of the hydrogens. Bases pull off the OH. So in a solution that is acidic, we are going to have more hydrogen ions. In a solution that is basic, we are going to have way more of these hydroxide ions, these OH ions. Strong bases are very, very strong electrolytes also. Um, Not all bases are ionic compounds. Some of them can be molecular. Again, an ionic compound is always going to be a metal and a non-metal. We already learned that. But some bases are going to be molecular. Sodium hydroxide is a strong base. Ammonia tends to be weaker. All right, so how do we go about measuring the strength of an acid? How do we go about measuring the strength of a base? What's that? We could, yes. Um, so oftentimes when we're going to measure these things, we do have to have things like in some sort of container, because most of the time these are going to be an aqueous solution, which means basically they're a liquid. What we are actually measuring, though, is we are measuring hydronium, the hydrogen ions, and we are measuring hydroxide, OH ions. Remember, ions have those charges in solution, and when they're in solution, we can detect them using a device called a pH meter. Traditionally, prior to electronics, they would use something called litmus paper or universal indicator. But it's the 21st century. We use a pH meter. So the pH value, we know this from yesterday, is a number anywhere between 0 and 14. The value reflects how many hydronium ions or how many hydroxide ions exist in that solution. Okay. And there's some math involved that you don't really need to know about, but just understand that it is a math thing. So, pH scale, anything below 7, getting further and further away from 7, we have increasing acidity. If you had an acid of a level 0 pH, that would, if you've ever seen those alien movies where like they shoot the aliens and then they hit the floor and then like the acid eats through the metal, that would be like 0 pH. Again, going on the other side, anything from 7 to 14, that is basic. And again, moving further and further away from 7, if you get into your 12s, your 13s, your 14s, those are where your strong bases are. The closer you are to 7, the more closer you are to neutral, the weaker the acid, the weaker the base is. And where the heck, pouvoir hydrogène, meaning the power of hydrogen. That's where that pH comes from for pH scale. Gotta love the French. They use a bunch of vowels, and they never actually pronounce them. All right, so this is what we're actually measuring. We are measuring the concentration of hydrogen ions. We are measuring the concentration of I keep saying hydroxide. Per, OH. There we go. Ions. The further away I get from neutral, if I'm neutral, you'll notice I have 1, 2, 3 peroxide ions. I have 1, 2, 3 hydrogen ions. In the middle, you have equal number. No, but I can forward this to you. I mean, this is just a picture. This is just kind of a picture of what it is that we're actually measuring when we're measuring pH scale. If you know that you get more hydronium ions, the OHs, as we get more basic, that is what this picture is intended to show. So if I'm here in the weak base area, I still see some hydrogens floating around, and I have some of these OHs. But the closer I get to 14, it's almost entirely all OH. You see that? That's what we're measuring. When I measure bases, I am actually, or measuring pH, I'm actually measuring the level of these ions. Yes. Okay. All right. Let me see if I can adjust that. I don't know what's going on, but I can happily turn up my volume. Give me one. How's that? Better? Okay. All right. I will talk loud and turn my volume up all the way. There's that. All right. So, if I'm looking at acidity, I am looking at hydrogen ions. Okay. So again, if I'm a weak acid, I see quite a few of these OHs hanging out still. But the closer I get down to 0 and 1, the higher the concentration of hydrogen ions are. As I get a stronger acid, the number of hydrogen ions increase and the number of OH ions decrease. And of course, the opposite of true for bases. So, another way of thinking about this is that as my acidity goes up, my hydrogen ions go up. And I have a low amount of OH ions. As my pH goes up, as my basic basicity, I don't know if that's a word or not, as I get more and more basic, the hydrogen ions go down and the OH ions goes up. So this is just another visual to think of pH. So again, just another way of thinking about it. It's whatever you are going to use the graphic, or you are going to internalize the graphic that works best for you. My job is to simply kind of show you a couple of different ways, and hopefully something sticks. All right. So, ladies and gentlemen, a pH scale. If I have a substance with a pH of 4, it is more acidic than something with a pH of 5. Because again, the further away I get from 7, the stronger the acid becomes. A substance with a pH of 11 is a stronger base than a substance with a pH of 8.5. Again, 8.5 is closer to 7. The further away you get from 7, the stronger your acids, the stronger your bases. One of the funny things that I saw like a million years ago, it was at some protest, and it was an environmental protest. And it was one of those things where, like, I totally understood what they were saying, but at the same time, I'm like, no, the science is wrong. They were protesting climate change, and one of the things with climate change is that we're seeing a lot more acid rain. And this lady had a sign that said, lower the pH of my rain, less acid in the rain. And I'm like, no, because if you lower the pH, then that means it's stronger acid. Anyways, it was one of those things that like I saw, and it was like people really need to make better protest signs. Anywho, again, pH scale, 7 neutral. The further away you get from 7, the stronger the acid. The further you get towards away from 7 and towards 14, the stronger the base. All right, so commonly in high school, because it's not like we have millions of dollars for these like lovely pH meters, we use what we call acid base indicators. These are liquid chemicals, sometimes they're in paper form, and they change color in the presence of ion. Some acid base indicators are phenolphthalein, methyl red, bromthiamyl blue, phenyl red, methyl orange, red wine, cabbage juice, and beet juice. So, one of the most commonly used acid base indicators was actually beet juice in early times because, well, I mean, it works. And these can give you an approximate pH value, but obviously, modern times, these meters are a lot more effective. Litmus paper, again, if it stays red or turns red, it is an acid. If it stays blue or turns blue, it is a base.